So the last portion of the presentation will just be some colorized animations that I did recently. We can kill the slide and do the video. This is panchromatic data, just black and white. With the shape and shading, you can derive the elevation, and using the elevation and the original data, I developed a color model where the lower areas are more of this rust colored that we see Mars in, and the higher areas tend to be less saturated and more washed out, and it gives it, I think, more of an interesting set of tonal and color variations. And I'll let the final judgment be up to the Mars experts here as to whether I've captured the color right. I used some of the lander photographs as a qualitative model. Okay. So I'll show you the colorized data, and then I have some animations showing some new perspective views. So here's 35A72. And we ran shape and shading on the full image, so we had this image, the elevation, and then from that we colorized it. So I did more than just coloring it red, and you'll see that in a minute when I zoom up to some of these features. Then the face and city, rotated. And the face. So the higher areas tend to be more grayer, and the lower areas reddish, more reddish colored. Now this is 7813. We started kind of in the front and below the face, and we're moving around to the left side. This is the object that I refer to as the fortress. Really unusual looking object. I don't know if any geologists have taken a real serious look at it. Very straight side here, regular indentations, and it almost kind of looks like it has a shoe appearance that kind of comes up in the back here. The D&M pyramid. It almost appears to have one of those ramps that the current theories on how the Egyptians built the pyramid was by building ramps or embankments to haul the materials up. It looks like there's something trailing up the back of it, but who knows? So I tend to like to see, or like to have the pictures speak for themselves. I hope the work that's been done thus far is sufficient, and hopefully in the next few years, if things go well, these objects will make it to the top of the priority list for Mars Observer 2 or Clementine or whatever else is sent to Mars. So with that, I'd like to take any questions. No questions? Chris, yeah.
Mark, I have a couple questions.
Yeah.
On the shape from shading, the first part of the work you showed, and as you reported in the Applied Optics paper, that was a very nice paper. One question I have is, as you know, any inversion technique is very tricky numerically, and you're not guaranteed of having a unique solution. In fact, multiple solutions. Just from looking at the equation, you can see that multiple solutions are allowed. So one question always is ground truthing such an inversion technique. And it occurs to me that there is altimetry data from Mars in certain lines from Mariner 9, from the altimeter. And so my question, or maybe it's a suggestion, is can you apply this technique to areas where there is good altimetry data? And then how well would you be able to retrieve that the profile of that altimetry with your shape from shading technique?
Yeah. Shape from shading, there's not enough information. I should say you have to make more assumptions in order to get metrically accurate results. The results are good relative models for the surface, but they're unknown to a scale factor and an offset. Okay. In fact, shape from shading has been, there's several techniques out there that have been developed to use shape from shading to interpolate elevation maps derived from stereoscopy, because it's good in filling in, but it's not metrically accurate. Now, the altimetry data, I think, is probably fairly low resolution, and shape from shading really works well over small areas. In the formulation I showed here, we're doing these strip integrations, and as you know, a technique like that's going to be very susceptible to noise. And so over large areas, if you run it over large areas without any kind of control, you're going to get a big buildup of noise and errors. So I think it's real good in extracting sort of the relative shape of isolated features, but probably not good, doesn't have good metric accuracy, particularly over large areas. Now, a way, you mentioned ground truth, a way that we checked, actually I didn't check the results, but colleague Brian O'Leary wrote in a paper in British Interplanetary Society, same issue that the fractal analysis came out in, and actually I worked with him on it. We took the surface derived from 35A72 and lit it to match 70A13. And we compared the two, and we did the same from 70A13 and matched 35A72. And there was pretty good agreement there. It's not a great validation because, to begin with, the two images were fairly close together, but there was some difference, and it did seem to match. Another point is that the applied optics technique, or the applied optics paper, used one shape from shading technique, which was based on a relaxation algorithm. A few years later, a guy that worked for me at TASS developed another algorithm based on a simulated annealing approach, which gave similar results. The relaxation algorithm, the surface was kind of overly smoothed out. The annealing algorithm gave a surface that was sharper, but it was noisy because it's a statistical algorithm. The technique I used here actually is none of the above. It's a simpler formulation, the strip integration approach. And this is a technique that Horn came up with in the 60s. And actually, he may have adapted it from earlier work done by, forget the gentleman's name, doing lunar terrain mapping in the mid-60s. But when the illumination is extremely oblique and you're looking nadir, you can show that there's a unique solution, at least in the direction of the light source, that a lot of the degeneracies, a lot of the problems that you have when you're close to the illuminant direction or things like that, they go away, and you have a very nice situation for shape from shading. And that's in fact very close to the situation here. The sun is 10 to 20 degrees above the horizon. You're looking in a nadir view. So that was the third technique. All three techniques kind of give the same result. Qualitatively, you look at the elevation surface, and you get a mesa that has certain gross features that resemble a forehead and a central ridge and some depressions. And the reason, and when you illuminate it, you get images that closely match the original. So the only validation I was really able to do was using these different images and different techniques. But I'd love to get 1 meter resolution data.
Yeah, who wouldn't? Other question is on the fractal analysis. There are other features on Mars that are obviously non-fractal, like the craters, for example, or the caldera of the volcanoes, or the North Polar Hood Barkhan dune fields.
Right.
Have you looked at those, and how do they, I guess the generalization of my question is, you've only looked at the images immediately around the face.
Yeah.
If you did a more of a, say, in some sense you're looking at what you're looking for. If you were surveying the planet without a predisposition to look at that particular image, would it really stand out as clearly as it does compared to the things near it?
Yeah, when I submitted these results for publication, a criticism was that I did a very small area, that I should do more. So I took all the data that I had, the neighboring frames, and I ran them. And in the 4 neighboring frames, it still stands up as being the highest hit. This was before CD-ROMs. I had 9-track tapes. There's a group in England that I gave a presentation on this at Goddard some years back, and I asked, or basically said, if anyone is interested in trying to duplicate or would like to do more extensive testing, here's a software. I got some takers over in England, and a guy that does some programming at Oxford University is currently trying to get the code running. Last I heard, it still wasn't working, and the documentation leaves a lot to be desired. It's always the case, but once they get the code running, they're going to try to apply it to a lot of the data that's now available on CD-ROM. So, I'm certainly open to others doing that. I didn't really have the resources at the time, and I still don't now. I don't really have the time, I should say. But if anyone's interested, I can make the software available, and I welcome further applications of the technique. Again, it's not proof or disproof. I kind of see it as a screening technique for identifying other candidate areas, if in fact we can prove that the methodology is valid. Any other questions?
Mark, the only thing that bothers me is when I look at that face, I see Louis Rukeyser. Has anybody put them together?
I'm sorry, I missed that.
Looks like Louis Rukeyser. That bothers me.
People see all sorts of things in it. Yeah, the key is not to look at it too long. Okay.
That's all of the questions.
Is that it? Okay. Thanks a lot.
Okay, we're going to have just a moment break again, and then we'll come back with today's last speaker, far from the least, and that'll be Vince DiPietro, and he's promised us some surprises on his presentation, so I'm looking forward to that now too. It'll be starting in just about a minute or two.